Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is a database design concept, but the new chapter, that is chapter number 15, that is a concurrency control. In the last class we have discussed about the chapter that is used, that is a chapter number 14 that we have discussed in the last class, that is transactions. Now next is the chapter number 15 that I am going to start in the today's class, that is the concurrency control. So let's start with the chapter number 15, that is the concurrency control. So first of all, what is the meaning of concurrency and why there is a need for the control, that is the concurrency control. So there is a need of the concurrency that is used or that is used to execute, that means more than one process are executing at the same time, that is a concurrency. That is, at the same time more than one task is executing, that is known as a concurrency. And whenever we want to control the concurrency, whenever there is approach, there will be a concept that is used to control the concurrency, that is that approach is known as the concurrency control. So there are multiple practices, and the most frequently used practice is the two-phase locking and the snapshot isolation that is used for the loop controlling, that is used for the maintenance of the controlling. So concurrency means when more than one transactions are executing at the same time, that is a concurrency, and there is a need to control them, that is known as the concurrency control. So in the chapter number 14 we have seen the fundamental properties of a transaction, that is a isolation. So one of the fundamental property that is used, that is known as isolation, and when the several transactions execute concurrently in the database, however the isolation property may no longer be preserved. So there is no preservation, there is no concurrently executing database, there is no more than one transactions are executing in the database. The isolation property is not preserved or is not taken, that is isolation property. To ensure that it is a system control must control the system must control the interaction among the concurrent transactions. So there will be a controlling among the concurrent transaction that is taken up. This control is achieved through one of a variety of the mechanisms that is known as the concurrency control schemes. So one of the mechanism that is used to control the various approaches, that is known as the concurrency control schemes. So concurrency control scheme means more than one transactions are executing at the same time. In chapter number 26, we discuss concurrency control schemes that admits non-serializable schedules. So the coming chapter, or the chapter number 26, that is the next 10 chapters, we discuss about the concurrency control scheme that admit the non-serializable schedules. In this chapter, we consider the management of concurrently executing transactions and ignore failures. So in this chapter, we study about how to manage the concurrency control, or how to manage the various concurrency control transactions and ignore the failures. In chapter number 16, we shall see how the system can recover from the failure. That is, what is the scheme, what are the mechanism that is used to recover from the failures. So as we shall see, there are a variety of concurrency control schemas, but we are using, or we are focusing on the most frequently used schema, that is known as the two-phase locking and the snapshot isolation. So these are the two parts that is very important, or that is the very basic for the snapshot, that is the snapshot isolation and the two-phase locking. So let's start with the two-phase locking first of all, and there will be a snapshot isolation. So one way to ensure that isolation is to require the data item to be accessed in a mutually exclusive manner. So whenever I want the transaction to be used in isolation, that means more than one transactions are executing at the same time. So there will be isolation, that is every transaction must executes individually. So one way to ensure the isolation is to require that data items to be accessed in a mutually exclusive manner. That is, while one transaction is accessing a data item, no other transaction can modify that data item. So if one is using the data item, one is accessing the data item, so there is no privilege of other transactions also that is used to take the data item. So no other transaction can modify that data item. The most common method that is used to implement this requirement is to allow a transaction to access a data item only if it is currently holding a lock on that item. That is, this is the most important mechanism that is used to implement that. It allows a transaction to access a data item, that only and only transaction access a data item if and only if it is currently holding a lock on that item. If there is no lock, that will not be accessed, or that will not be considered as a true transaction. So if there is a lock, so that means locking the transaction means holding the transaction for the user, so that only the user, specified user, can hold the or can use the transaction. We introduce the concept of locking in section 14.9. Now next is what are the locks. So there are various modes in which the data item may be locked. So there are various methods, there are various modes by which the data item may be locked. In this section, we restrict our attention in two modes. So there are two types of logs that is available. One is the shared log, one is the exclusive log. So there are two logs, one is the shared, one is the exclusive log that is used to shared among the various transactions. So first is the shared log, that is what is the meaning of the shared log. So if a transaction T1 has obtained a shared log or shared mod log on item Q, then Ti can read but cannot write Q. That is, shared log means it is shared by more than one transaction, it is shared by two transactions. So if a transaction Ti has obtained a shared mod log, so if it is a shared mod log that is denoted by the S on item Q, then Ti can read but cannot write the Q. So Ti has a facility to only read the data but cannot write the data, that is cannot write, that is Q. Now there is exclusive log, that is the exclusive mode log that is used in this. There is no shared log, but this is the exclusive mode log. If a transaction Ti has obtained exclusive mode log that is denoted by the X on item Q, then Ti can both read and write the Q. So Ti has a facility to read as well as the write the content into the Q, that is on item Q, because this is the exclusive mode log. This is the log, that is this is the, we can say, the first type, that is a shared, this is exclusive. So if there are two shared log, that is a true, this is a true, and the false, that this is the false, this is the false. That is a log compatibility matrix comparison. We require that every transaction request a log in an appropriate mode on data item Q depending on the types of the operations that it will perform on the Q. So whenever every transaction requests a log, request a method in the appropriate mode on the data item Q, that depends on the type of operation. What are the type of operation that will perform or that will be used on the Q? So there are multiple operations that will be used on the Q transaction or the Q data items. The transaction makes the request to the concurrency control manager, and the transaction can proceed with the operation only after the concurrency manager or concurrency control manager grants a log to the transaction. So that will proceed only if there will be a concurrency control manager that grants the log to the transactions. The use of these two log modes allows a multiple transaction to read a data item but limit write access to just one transaction at a time. That is, if I'm using both the logs, that is the shared log as well as the exclusive log, so that will allow the multiple transaction to read out the data but limits the write access to just one transaction at a time. That is, we can read the both the transaction but cannot write the transaction at once. To state this more generally, given a set of log modes, we can define a compatibility function on them as follows. Let A and B represents arbitrary log modes. Suppose that a transaction Ti requests a log of mode A on item Q, on which transactions Tj currently holds a log of mode B. If a transaction Ti can be granted on a log Q immediately in spite of the data, then we can say that A is compatible with mode B. So if there are exclusive logs, there are shared logs, there are multiple methods in which we can use the mechanism, we can share the mechanisms. So to maintain the compatibility or to maintain the correctness or to maintain the compatibility among the various transactions, there will be a need, there will be a transaction that the two modes will be used in a concurrent way, that the shared mode and the exclusive mode will be used in the compatible way. So note that the shared mode is compatible with the shared mode, but not on the exclusive mode. At any level, several shared mode can be held simultaneously. That is, more than one shared log can be used simultaneously, but we cannot use the shared log and the exclusive log at the same time. To access a data item, transaction Ti must first log that item. If the data item is already logged by another transaction in incompatible mode, the concurrency control manager will not grant the log until all compatible logs will be held by the other transaction have been released. So if any other manager, if any other transaction also holds the log, if that is a compatible log, so it will not be maintained by the transaction, it will not be taken by the transaction until it is logged by the or until it releases each and every transactions. To access a data item, the action must first log the transactions. Therefore, the TI must to wait until all the incompatible logs held by other transactions have been released. So it will be logged by other transactions, that will be given by other metrics, that will be held by the other metric that is used for the development of the matrices. So transaction TI may unlock a data item that it held lock at some earlier point. Note that the transaction must hold a lock on that data item as long as it accesses that item. And moreover, it is not necessary or desirable for a transaction to unlock a data item immediately after its final success of data item is done. This is one of the example. This is first of all one transaction is locked, that is locks xb, then read xb, then there will be operation that will be b equals to b minus 50. That is whatever the value that will carried out, that will be subtracted, or 50 will be subtracted from that value. Then write b, then unlock b. That means unlocking the b again. Then there will be a log, that is the xa, then the read a, then again adding the values of the 50 to the a, then write a, then unlock a. So as an example, consider again the banking example that we introduced. Let A and B are two accounts that are accessed by the transaction T1 and the T2. There are two transactions and there are two accounts, that the T1 and the T2. T1 transfers 50 from the account B to the A. That's why B is debited from the 50 is debited from the B and it is credited to the A. That is the transaction T1 transfers the order 50 from the account B to the account A, and the transaction T2 displays the total amount of money in the account, that is the A and B. That is the sum A plus B. Suppose that values of A and B are 100 to 100 respectively. If two transactions are executed serially, then in the order T1 or T2, or the order T1 T2 or the T2 T1, then execution or transaction T2 will display the output, that is a 300. However, the transaction will be executed concurrently with the schedule 1. In table or figure 15.4 it is shown. This is the schedule that shows the various transactions. This is the transaction 2, that is only log, then read, then unlog. That means this is the scenario that is used in which there is no transaction, in which there will be a display total amount of money in the account. Whatever the total amount that will display, that is a plus B. So this is A, this is B, then it will display A plus B, that will the total amount of the whole or both the transactions. This is T1, then T2, then concurrency control manager. This is the T1 phase, this is the T2 phase, and this is the concurrency control manager. Suppose that unlocking is delayed at the end of the transaction, then transaction T3 corresponds to T1 with unlocking delays. Transaction T4 corresponds to T1 or T2 with unlocking delays. So if transaction T2 has to unlock the transaction without any contacting with the T2, that is also possible in case of the sequences. These are the various examples that is used, and whenever there are multiple scenarios, or whenever there will be a state where neither of the transactions can even proceed with its normal execution. So it cannot proceed beyond the normal execution or beyond the normal procedure, that is known as the deadlock. So deadlock is a condition, deadlock is a scenario that is used in which there is no transaction that is unlocked, that is unlocked by the transaction, that is neither of the transaction can even proceed before with its normal execution, that is they hang with each other, that is known as the deadlock. However, if we do not use locking, or if we unlock the data item too soon after reading or writing, we may get an inconsistent state. So there will be an error, there will be a connection maintained, that is an inconsistent states. This is the scenario that is used, that is a T3, that is log, then read, then B, write B, then log, read, log, then log, XA. So we shall use the transaction follows the set of rules that is known as a locking protocol. That is, if one data item is locked by one transaction, that it will not be locked by another transaction, indicating when a transaction may lock and unlock each of the data items. Locking protocols restrict the number of possible schedules, and the set of all schedules is a proper subset of all possible serializable schedules. We shall present several locking protocols that allow only conflict serializable schedules and thereby ensure the isolation. Before doing so, we introduce our some terminologies. So next is the granting of logs, that is who one can access the logs and who is responsible to access the logs. So when a transaction requests a log on a data items in a particular mode and no other transaction has a log on the data item, that is no transaction has a log on the data item that is used, so anyone can access the data item, anyone can get the data item, that is anyone can grant the data item if he has a facility. So if the other transaction has a data item on the conflicting mode, the log can be granted. However, care must be taken to avoid the following scenarios. Suppose a transaction T2 has a shared mode lock on the data item, And another transaction, that is T1, request an exclusive mode log on the data item. Clearly T1 has to wait for T2 to release the shared mode log. Meanwhile, the transaction T3 may request a shared log on the same data item. So there are two, first of all, T1 has to wait until the T2 released. Now T1 also comes in the picture and also requests for a shared mode. The log request is compatible with the log granted to the T2. So T3 may be granted to the shared mode log. So it will go to the log will go to the T2, and the T3 automatically get the shared log from the T2. At this point T2 may release the log, but still T1 has to wait for T3 to finish. But again there may be a new transaction, that is T4, that requests a shared mode log on the same data item and is granted on the log before T3 releases it. In fact, it is possible that there is a sequence of transactions that each request a shared mode log on the data item. The T1 is not executed, and the T1 never progress, or the T1 and carry on progress, that is known as the starboard. That is the scenario that is used, that is when more than one transaction is using, or when more than one scenario is using on the transaction, that is the T1 never executes or progress, that is known as the starboard process. And we can avoid the starvation of the transactions by granting the logs in the following manner. So this is a scenario, that is how to or how to control the managers, or there will be a concurrency control manager that grants a log provided that. So there is no other transaction that holding a log on the queue. So there is no mechanism of holding the log, or there will be no scenario for holding the log that is on the queue in a mode that conflicts with the and there is no other transaction that is waiting for a log on the queue. So there will be a transaction that is waiting for a log, that is holding a log. There are two scenarios in this. Therefore, a log request will never get blocked by a log request that is a made later. Now next is a two-phase locking protocol. That is a two-phase locking protocol in which there will be a protocol that is used. There are two phases in this one. One is a growing phase, one is a shrinking phase. This is a growing phase and this is the shrinking phase. What is a growing phase? Whenever the transaction is releases, or whenever a transaction may obtain the logs but may not release any logs. And the shrinking phase means a transaction may release the logs but may not obtain any new logs. That is, one is a growing phase, that is may obtain the logs but not release any logs. That is a growing phase. One is a shrinking phase, that is release the logs but not obtain the new logs. That is, only release the logs but not obtain the new logs. And the growing phase means only obtain the logs but not release the logs. That is a growing phase. So one is a growing phase, one is a shrinking phase. So one protocol that is used, that is known as the two-phase locking protocol. This protocol requires that each transaction issue lock and unlock request in two phases. So there are two phases in this one. One is the growing phase, one is the shrinking phase. Initially, a transaction is in the growing phase. So first of all, whenever we obtain any transaction, that the transaction is in the growing phase. That is, the transaction is used in the growing phase. So growing phase means obtain the logs but not release any logs, and the shrinking phase means release the logs but not obtain any logs. That so that it release each and every log, so that it will not be maintained by the log, it will not be used any log. So automatically the logs will be removed. That is the shrinking phase. And the growing means obtaining the logs. So initially a transaction is in the growing phase, and the transaction requires the logs as needed. So when the transaction releases a log, it enters a shrinking phase and it can issue no more log request. For example, transaction T3 and the T4 are two phases. So there are two phases, one is the T3, one is the T4. On the other hand, T1 and the T2 are not two phase. Note that the unlock instruction do not need to appear at the end of the transaction. For example, in case of the transaction T3, we cannot move the unlock B to just after using the XA transaction. So there will be a point, that is a local point, in which the schedule where the transaction obtains its final log, that is at the end of the growing phase, that is known as the lock point of the transaction, that is the final stage. And two-phase locking does not ensure freedom from the deadlock. This is one of the limitation of the two-phase locking protocol, that it does not ensure, or it does we can say it did not carry out the deadlock. That is one of the method. Observe that the transaction T3 and the T4 are of two phases, but in schedule 2 that they are deadlocked. That is, this is one of the we can say the disadvantage of the two-phase locking protocol, that is cannot avoid the deadlock. Cascading rollback can be avoided by a modification of two-phase locking protocol, that is known as a strict two-phase locking protocol. That is we can apply the rollback, we can apply the cascading rollback in which the modification can be done on the two-phase locking protocol, that is known as the strict two-phase locking protocol. This protocol requires not only that locking be two-phase, but also the exclusive lock mode will be used, or the exclusive lock method may be used to the transaction until the transaction commits. So until the transaction makes the commitment, so we can use the locks, we can carry out the locks that will ensure the making transactions. Another variant of the two-phase locking protocol, or another category of the two-phase locking protocol, is the rigorous two-phase locking protocol, which requires that all the locks that need to be held until the transaction commits. This is one of the scenario. One is the T5. This is one of the lock that is unlock the A, then T3 also locks the A, then unlocks the A, then only the T7 unlocks the A. So this is a partial schedule under the two-phase lock protocol, that is a two-phase locking protocol that is used to give the scenario, that is used to use the scenario between the transaction, that is the T5, T6 and the T7. And we can easily verify that with the rigorous two-phase locking, the transaction may be serialized in the order in which they commit. Now consider the following transaction, or consider the following two transactions for which we have to show only some of the significant read and write operation. This is one of the read operation, this is one of the write operation. And if we employ the two-phase locking protocol, then T3 must lock the A1 in the exclusive mode. And the observation that is used for the two-phase locking protocol, in which the lock conversions are not allowed, that is known as the locking protocol. And there will be exclusive lock or exclusive mode that will be used to autograde or upgrade the method, that is from the exclusive to the shared lock by the downgrade. This is the T8, this is the T9. This is the incomplete schedule with the lock conversion. Returning to an example, transaction T3 or the T8 and the T9 can run concurrently under the refined two-phase locking protocol as shown in the incomplete schedule of the 15.9. This is the incomplete schedule because this is a one locking. There is no unlock, but the another person or another transaction will use that. Another transaction will use that, another transaction. That is unlock at the end of the transaction. Just as the basic two-phase locking protocol, the two-phase locking protocol with lock conversion guaranteed only conflicts, serializability, and the transaction can be serialized by their local points. Strict two-phase locking and the rigorous two-phase locking are exclusively or mostly used in the commercial database system. A simple but widely used scheme that automatically degrades the appropriate lock and the unlock instruction for a transaction on the basis of read and write request from the transaction. These are the various requests that is used for the locking. Now, when a transaction TI issues a read queue operation, the system issues a lock SQ instruction followed by the read queue instruction. When TI issues a write operation, the system checks to see whether TI already holds a shared lock on the queue or not. Now all locks obtained by the transaction are unlocked after the transaction commits or aborts. So if the transaction is commits or if the transaction is aborts, then automatically the locks are free. That is, automatically the locks are converted into the unlocks mechanism. The next is the implementation of locking, that is how to implement the locking mechanism. So a lock manager can be implemented as a process. So one is a manager that is known as a lock manager, that is a process that receives the messages from the transactions. So this is how to implement a locking scheme, or how to implement the two-phase locking, that is a rigorous or the implicit locking. So a lock manager can be implemented as a process that receives the messages from the transactions and sends the messages in the reply. So a lock manager can be implemented as a process. So this is a process that receives the messages from the transaction. So it receives the messages from different transactions that is executing and give the reply in the, or give the messages in the reply. So it gives the messages in the reply that will keep the manager, that will maintain the managers in the queue. That is implementation of the locking. That is the process that receives the messages from the transactions and sends the messages in the reply. The lock manager process replies to the lock process messages with lock grant messages or with messages requesting rollback of the transactions. So it is the responsibility of the lock manager that process that replies to the lock manager messages with the grant or the lock grant messages. Unlock messages requires only an acknowledgement in response. So whenever or whatever the unlock messages that requires an acknowledgement in the response, but may results in a grant message to another waiting location. The lock manager usually or uses the data structure that is uses this data structure that is used. For each data item that is currently locked, it maintains a linked list of the records, one for the each request, and in the order in which the request arrived. It uses the hash table index on the name of the data item to find the linked list, if any, for a data item. This table is known as a lock table. So there will be a table that will maintain the name of the data item, that will maintain the data item that will use, that will done with the transaction, what lock will be requested. The record also notes if the request is currently being ignored. For example, figure 15.10 shows an example of the log table. The table contains logs for the 5 different data items. These are the 5 different data items. The log table uses overflow chaining, so there is a linked list of data item for entry in the log table. There, there is also a list of transactions that have been granted logs or are waiting for the logs for each of the data items. Granted logs are the rectangle filled in the darker shade. So what are the granted logs? That is filled in the darker shade, that is filled with the various rectangles. Although the figure does not show it, the log table should maintain an index on the transaction identifier. So it is possible to determine efficiently the set of the logs that is held by the given transaction. And the log manager processes the queries or processes the request queries that is used in the way. Now what are the scenario, that is how to implement the locking in the database. So first of all, when a log manager when a log request message arrives, it adds a record to the end of the link list for the data items if the linked list is present. Otherwise, it creates a new linked list containing only the records of the request. So whenever a log manager or whenever a log request message arrives, it adds the records to the end of the linked list for the data item if the linked list is present. Otherwise, it creates a new linked list containing only the record for the request. Next is always grants a lock request on the data item that is not currently being locked. Next, when the lock manager receives an unlock messages from a transaction, it deletes the records of the for that data item in the linked list corresponding to the dead transaction. So it deletes the record for the transaction that will include the linked list. It tests the records that follows, if any, as described in the previous paragraph, to see that if the request can now be granted. Next, if the transaction aborts, the log manager deletes any waiting request made by the transaction. If the transaction aborts, or if the transaction, we can say, the fails or the aborts, then it's the responsibility of the log manager to delete any waiting request that is made by the transaction. These are the three scenarios in which the log manager processes the queries. So when the log manager requests, the message arrives, then receives an unlock messages, then receives the log manager that deletes the messages. This is the figure that shows how the transaction T3, T1, T8, T2 are runs in a parallel way. This is the T23, that is the T1, T23, and these are the different shades that is used as the legends for showing what are the various phase or what are the various granted phase and what are the various waiting phase. So this dark blue shows the granted phase, and this we can say the light blue shows the waiting, or the sky blue shows the waiting phase. This is the log table. Now this algorithm, whenever we use a locking algorithm, that algorithm guarantees the freedom from starvation for the lock request. So that means there is no hard and fast locking mechanism. That is, if the one transaction is in the lock phase, another cannot be used for that transaction. So that is freedom for the from the starvation for the lock request. Since a request can never be granted by the request received, there is waiting to be granted. Now we will study and detect the hard deadlock in the later sections. Now next is a graph-based protocol. That is the next phase. So that means whenever we use the graph-based protocol, that is using the graphs by using the histogram like this one, by using the tables, by using the histogram for making the protocol, for making the implementation of the two-phase locking protocol, that is a graph-based protocol. This is one of the scenario that is used. This is the data graph base graph that is maintained for the acyclic graph that is maintained, and this employs the exclusive lock. and in the T protocol only the log transaction instruction is allowed the log mechanism, and the log TI can log a data item at most once. All schedules that are legal under the tree protocol are conflict serializable. To illustrate the protocol, consider the database graph. The following four transactions follows a tree graph in the tree protocol in this graph. This is the tree structure graph. This is the A. These are the various leaf nodes. B. These are the E and F the leaf nodes. Then E, I. And the B also gone for the D, D, C and G and the H and the I. This is the T10. That is the T10 used. That is the log XB, XC, XD. Now next is the deadlock handling. That is the next topic, that is how to handle the deadlock. So in this we have only studied that there will be deadlock that maintain. Now next is the scenario, that is how to handle the deadlock. So let's take a break right now, then after the break come back, then move to this topic, that is the deadlock handling. Let's take a break. Come back from the break. Now let's start the session again. Now the next topic is deadlock handling, that is how to handle the deadlock. Now what is a condition or what is a deadlock? So whenever the transaction never proceeds further, that is a deadlock. Now what is the scenario, how to handle the deadlock, what is the very condition that is used to handle the deadlocks? So a system is in deadlock state if there exists a set of transactions so that every transaction is set in the waiting for another transaction in the set. That is, one transaction is waiting for another, another transaction is waiting for another. So there will be a chain. That means every transaction is waiting for another transaction in the set, in the group, in the loop. More precisely, there exists a set of waiting transactions that is from T0 to Tn. So the T0 is waiting for data item, T1 holds, T1 is waiting for the T2, Tn is waiting for the next data item, that is a Tn holds, and the Tn is waiting for the data item that T0 holds. That means there will be a loop. That is, one is waiting for last is waiting, one is waiting for second is waiting for third, fourth, so on, and the last is waiting for first one again. That is in the loop. The only remedy to the undesirable situation is to system to invoke some drastic actions such as rolling back some of the transactions involved in the deadlock. So to remove this one, there will be a scenario, that is rolling back all the transactions that is present in the deadlock, and the rollback may be partial. That is, if one transaction is if 5 transaction is in the deadlock state, how can we judge which transaction is to be rolled back? That will be a partial scenario. That is, a transaction may be rolled back to the point where it obtained the log whose release resolves the deadlock. There are two principal methods for dealing with the deadlock problem. So how to handle the deadlock? There will be a two principle that is used. We can use a deadlock prevention control. There will be deadlock detection, and there will be deadlock recovery. So one is the deadlock prevention, that is, before getting into the deadlock or before deadlock is operated, there will be a prevention mechanism that will prevent the deadlock, and there will be a deadlock detection. That means after the deadlock has come, there will be a detection that is known as a deadlock detection, and there will be deadlock recovery to recover the deadlock mechanism. So we use the deadlock prevention protocol to ensure that the system will never use or enter a deadlock state, that the system will never enter into the deadlock state. That is the scenario. And the alternate way, we can allow the system to enter a deadlock state and then try to recover by using the deadlock detection and the deadlock recovery scheme. As we shall see, both methods may result in the transaction rollback. That is, both the methods can be used for the transaction rollback, that is the deadlock detection and deadlock recovery. And we can enter the deadlock state in the higher value, that is, otherwise the detection and the recovery are more efficient. Now the detection and the recovery scheme requires some special overhead, that is, the cost is very high, not only the runtime cost but also require the additional code for the use of the algorithms. Now first is the deadlock prevention, then deadlock detection, then deadlock recovery. So there are two approaches for the deadlock prevention, that is, there are two approaches by which we can prevent the deadlock. One approach ensures that no cyclic waits can occur by ordering the request for the logs. That is the one of the approach that ensures that no cyclic waits, or there will be no cyclic waits that can occur by ordering the request for the logs or requiring all logs to be acquired together. The other approach is to use or closer to the deadlock recovery and perform transaction rollback instead of waiting for a log. So one is the no cyclic wait, that is, no cyclic means no looping will be maintained by the scenario, that is, T1 is opting for T2, waiting for T2, T2 is waiting for T3. No, there is no cyclic wait that is used. The another approach is very closer to the deadlock recovery, that is, make the transaction roll back. instead of waiting for the log. So automatically it will roll back that the transaction will not be fulfilled. The simplest scheme under the first approach requires that each transaction logs all the data item before it begins execution. Moreover, either all of the logged are in one step or the none are logged. There are two disadvantages to this protocol. One is that it is often hard to predict before the transaction begins with which data items to be logged. So this is a disadvantage because we have to prevent the transaction, we have to prevent the deadlock. So we cannot judge in the starting phase that is which data item must be logged. Then data item utilization may be slow because many of the data item may be logged but you are unused for the long time. That is the wastage of money, wastage of the timing. Another approach for preventing the deadlock is to impose an ordering of all data items and to acquire that the transaction log data items only in a sequence consistent with ordering. That is, there will be a system, there will be a sequence of the transaction, that is the one transaction is executed, then next, then next, then next. That is the there will be a proper sequence of transaction that must be executed in the time. A variation to this approach is to use a total order of the data items in connection with the two-phase locking protocol. Now the second approach for preventing the deadlock is to use preemption and the transaction rollback. So there will be a preemption, there will be a deadlock prevention that will be used, that will be make the scenario that will unlock the transactions. Now, if the transaction is rolled back, it retains its old timestamp when restarted. So when the transaction is rolled back, it retains its old timestamp, that is the old timing that will be or when the restarted. The different deadlock prevention schemes using timestamp have been proposed. These are the deadlock prevention mechanism. First is the wait and the die scheme, that is a non-preemptive technique. Then wait and or wound and the wait scheme, that is a preemptive technique. So this is, one is the wait and the die, that is a non-preemptive. One is the wound and the wait, that is a preemptive technique. Another approach is based on the time or the log timeouts. In this approach, a transaction that have requested a log waits for at most a specified amount of time, that is a log timeouts. If the log has not been guaranteed within that time, the transaction is said to be timeout or it rolls itself back and restarts. The timeout scheme is particularly easy to implement and works well if the transactions are short and if long waits are likely due to deadlocks. Now, next is the now this is a scenario that is hence the time-based scheme has limited applicability. That is, there is no application that is used. There is no applicability that is used in the case of the time-bound scenarios. Now next is the deadlock detection and the recovery. That is how to detect the deadlock and how to recover from the deadlock. So if the system does not employ some protocol that ensures deadlock freedom, then a detection and the recovery scheme must be used. An algorithm that examines the state of the system is invoked periodically to determine whether deadlock has occurred or not. If one has, then the system must attempt to recover the deadlock. There will be a mechanism, there will be a scenario that will be used to get the deadlock or to see the deadlock, or there will be an attempt to get the deadlock, that is which deadlock is used or what are the scenarios that will use the deadlock, and if the deadlock has occurred, so what are the various schemes to recover from the deadlock. So for recovering from the deadlock, the system must maintain information about the current allocation of data item to the transaction. That is, every information is maintained for each and every current allocation of data item to the transaction as well as any other outstanding data item request. That is, what is the current allocation of data item and what are the various outstanding data item requests that is present in the scenario. Next, provides an algorithm method or provides an algorithm to detect the transactions to ensure that the work uses this information to determine the system has encountered a deadlock state. Then recover from the deadlock when the deadlock detection algorithm determines the deadlock exists. Now next is the deadlock detection. One is the deadlock prevention, one is the deadlock detection. This is the wait and try graph that is used. This is the wait and try. This is the wait graph, that is the T17 is waiting for the transaction, T17 is waiting for the T18 and the T19, and the T18 is waiting for the T20, and the T17 is also waiting for the T19, T19 is waiting for the T18. Since the graph has no cycle, the system is not in the deadlock state. although the every transaction is waiting for another transaction, but there is will not be a looping, there will not be a cycle. That is why it is not a maintained cycle. That is not a deadlock mechanism. Now suppose the graph has no cycle, the system is not in the deadlock state. Now T18 is carried out to the T20. This is T18, then T20, then T19, then T18. This is T19 and the T18. So these are questions that arises when we invoke the detection algorithm. How often does a deadlock occur? So how frequently the deadlock occur? That is one of the important questions that occurs. How many transactions will be affected by the deadlock? Then recovery from a deadlock, that is how to recover from the deadlock, that is a deadlock recovery. So when a detection algorithm determines that the deadlock exists, the system must recover from the deadlock. So first of all, it determines that there will be a deadlock that perceives. Now there will be algorithm, there will be a mechanism to remove the deadlock, or to, we can say, the recover from the deadlock. System must recover from the deadlock. The most common approach is to roll back one or more transaction to break the deadlock. That is, rollback means only abort the transaction, turn back the transaction, and whenever there will be a time, that transaction will be uploaded again. So the most common solution is to roll back one or more transaction to break the deadlock. And there are three actions that will be used to roll back the transactions. One is the selection of a victim. So first of all, whatever the content, whatever the scenario, whatever the, we can say, the transaction, whichever the transaction is using or maintaining the deadlock or create the deadlock, first of all, selection of a victim. Then there will be a rollback. That is, once we have decided that a particular transaction must be rolled back, we must determine that how far this transaction should be rolled back. The simple solution is total rollback. Now total rollback means rolling each and every part of the transaction, that is about the transaction and then far, or then restart it. However, it is more effective to roll back the transaction only as far as needed to break the transaction. Such partial rollback requires the system to maintain additional information about the state of all running transactions. Now next is the starvation. That is the next approach for the deadlock detection. In a system where the selection of the victims is based primarily on the cost factors, it must happen that the same transaction will be picked up as a victim. As a result, this transaction never completes its task, so there will be a starvation. That is, the starvation means without any food, without any shelter. In the same way, starvation means not completed the task fully. We must ensure that the transaction can be picked up as a victim only a small amount of finite amount of times. The most common solution is to include the number of rollbacks in the cost factor. That is, include the number of rollback, or include the number of making the transaction rollback, so there will be no detection algorithm or mechanism. Next is the multiple granularity. That is the multiple granularity. So when whatever the mechanism that is used to allow the multiple levels of the system, that is known as the multiple or granularity. This is a granularity hierarchy, that is, one system is linked to the another one and another one. That is the granularity. This is the mechanism that is used, that is there are multiple transactions that is using the granularity. Now next approach is the timestamp based protocol. That is the next approach that is used. So there will be a timestamp protocol that is used, that is a linkage protocol, that is a locking protocol that is used in the timestamp ordering method. So there will be a timestamp, that is which each transaction Ti in the system, for example, there is a transaction Ti in the system, we associate a unique fixed timestamp. So there will be a unique fixed timestamp that is available for each of the transaction, that is denoted by the TSTI, that is a timestamp Ti. This timestamp is assigned by the database system before the transaction Ti starts execution. The transaction Ti has not been assigned TSTI, the new transaction in the system, and the TSTI is less than TSTJ, so there will be a two simpler method for implementing the scheme. First of all, uses the system clock for the timestamp, then uses the logical counter for obtaining the timestamp. So there are two types of timestamps. One is a W timestamp, one is a R timestamp. And this protocol reads the transaction, reads and writes the operations in the timestamp order. This is one of the scenarios, that is the first of all read B, read A, then display the A plus B. The protocol can generate the schedules that are not recoverable. However, it can be extended to make the schedules recoverable in one of the following ways. That is the recoverability and the cascadeness. Then recoverability and the cascadeness cannot be guaranteed, can also be guaranteed by using a limited access. Now next is the Thomas try tool. That is one of the important tool. That is the Thomas try tool. This is one of the rule that is available, that allows the potential concurrency that does the protocol that is rolled back. These are the Thomas Wright rule that is available. These are the three rules. That is, if TI is less than R timestamp, then the value of Q that TI is producing was previously needed. Then TI is less than W timestamp, that TI is attempted to write an obsolete value of the TQ. Otherwise, the system executes the write operation and sets the timestamp of TI. The next is the validation based protocol. That is, what is a validation based protocol? This I am going to start in the next class, that is in tomorrow's class. So that's all for today's session. If there is any doubts, any confusions, you can ask the doubts from me. So thanks a lot everyone for listening me. We will meet tomorrow with the same concept with this protocol, that is the validation based protocol. So thanks a lot everyone. Bye bye.